All right, today we are going to start in chapter 4. We're in section 4.1, which is graph exponential growth functions. I believe we do exponential growth functions in algebra 1 as well, so this should look sort of familiar to you. We're just going to expand on it. So first of all, an exponential function has the form y equals a times b to the x. Okay, so this is how these are always going to look, where a is not 0 and the base b is a positive number other than 1. If it was 1, it would just be a straight line, right? That'd be linear because 1 raised to anything is just itself. If a is greater than 0 and b is greater than 1, then the function y equals ab to the x is an exponential growth function. It's an exponential growth function because it's going to be going up. And then we call b the growth factor. So we have this nice box here that kind of summarizes all of this information. So the function f of x equals b to the x, where b is greater than 1, is the parent function for the family of exponential growth functions with base b. So in the last chapter, we talked about those parent functions and we translated them around, we moved them around. We're going to do similar stuff with this as well. So the general shape of the graph of f of x equals bx is shown below. So it's always this kind of loopy thing like this. I want you guys to notice it never crosses the x-axis here, okay? Sometimes it will if we translate it down, but we're going to see those later on. But the reason is it has something called an asymptote. So if you look right here, the x-axis is an asymptote of the graph. An asymptote is the line that a graph approaches more and more closely, and this should say, but never crosses. It never even touches it. So that's what our asymptote is. You're always going to have a horizontal asymptote for these. So I'm just going to say always will have a horizontal asymptote. So that's going to be part of your range. The domain is all real numbers, but the range is always going to be your asymptote or greater. If it's flipped, it might be your asymptote or less. So let's look at what that looks like. So for example 1a, we're going to graph the function, and we're going to state the domain and range. So you can still do this in your graphing calculator. For this, y equals 2 to the x, you're going to type 2, the caret button, and then your x. So y equals 2, the caret button, and then your x in your y equals table. And then you go second table. When you pull up your table, you're going to have to scroll around because you're going to get some decimals. You need to decide what you're going to take this to. So I'm going to just graph, let's see here, -3 is at 0.125, -2 is at 0.25, -1 is at 0.5, 0 we're at 1, 1 we're at 2, 2 we're at 4, and 3 we're at 8. So if you graph this, I'm just going to count by ones here. X equals -3 is at 0.0125. That's basically sitting on our x-axis. -2, it's a tiny bit more. -3, it's -1, it's halfway between 0 and 1. And then at 0, we're at 1. At 1, we're at 2. At 2, we're at 4. And at 3, we're at 8. So you can see these grow pretty quickly. Again, when you draw this, make sure it never crosses that 0. It can look like it's sitting on it, but if you zoom in, you will never see that that gets to 0. All right, so make sure you're drawing this nicely. It should see points. A couple of you were pretty messy with your graphing in the last chapter, which I haven't passed those back yet, but some of them will need to be fixed. So make sure you're graphing these nicely, and you can always check your work in your calculator or on Desmos as well, because I had a couple people who drew very weird graphs that are just not correct. So make sure you're checking your work. The domain here then, let me highlight my domain in yellow. So domain is all x values that are possible. So if you think, you know, here, these are all possible, right? It's looking this direction. So that's why for these ones, you're always going to have the domain. It's all real numbers. Oh, that turned weird. All real numbers. Remember we had an abbreviation for that. You could just put this fancy R. The range is our y value. So this is a little different. For the y values, remember it can't go below this asymptote. So I'm going to actually draw my asymptote here, just so we can see it. This is my asymptote, and it might be helpful to draw that, okay? So my asymptote was at y equals 0. Okay, so that is my asymptote, y equals 0. But my range then is going to be y greater than 0. Notice it's not greater than or equal to. It has to be just greater than. It cannot be equal to it. I'm going to do a little note here even. Y cannot be equal to, whoa, it's a weird one, to 0. Okay, it's very important that you don't put the equal to. And that's how we're going to do these problems. Let's do example 2 together. And we'll just see how this will change it a little bit. So for example 2, part A, we're going to graph the function, state the domain and range. Again, I'm just going to make a table. Welcome to do that. And you can choose your x values. Just plot, probably 5 of them would be good. So 1/2 times 4 raised to the x. When you put this in your calculator, by the way, make sure you have this thing, whatever's in front of this, in parentheses, because you want to make sure that it's just raising the 4 to the x, because the 1/2 is not raised to the x. So when I typed this in, I typed in 1 divided by 2, parenthesis, and then 4 caret x. So then in my table, so for this one, whoops, x and y, I'm still gonna write -3, but it's gonna be really hard for me to graph some of these because these ones are even smaller, because that 1/2 makes them even smaller. So at -3, it's actually at 0.008. At -2, we're at 0.03. At -1, we're at 0.125. At 0, we're at 0.5. At 1, we're at 2. And at 2, we're at 8. And at 3, we're at 32. So you can see how fast this grows. So I want you guys to notice something, first of all. Notice at 0, we were at 1/2. And notice A is 1/2. You're always going to see whatever your A value is at x equals 0. So that happened here too, but our A value was 1, right? Because if you were to identify y equals A times B to the x, there is no A, so of course that must be 1. So that's going to happen every time, so that's kind of a helpful thing when you're graphing these. -3 is at almost 0, but not quite. -2, same thing, almost 0, but not quite. -1, same thing actually. And then at 0, we're at 1/2. At 1, we jump up to 2. At 2, we jump up to 8. And then 3 is going to be off my graph, so I'm not even going to graph it. So then we connect these points, and this just shoots up, basically. I'm going to go ahead and still draw my asymptote. So my asymptote is still this line here. And you can tell your asymptote if you look in your table and you just scroll, you're going to see that you can get closer and closer to 0. It should be easy to spot. Most of the time for these, if there's no plus or minus, it's going to be 0. So we have y equals 0 as our asymptote. My domain, just as in before, it's all real numbers. And then my range, it starts at the asymptote, so it starts at 0. And it can be anything above that. So y is greater than 0. Let's look at b. So notice for b, we have a minus out front. So that's going to change some things. So I'm going to go into my y equals. I hit negative and then parenthesis 5 divided by 2. Close those parentheses, raised to the x. So that's really important that you have parentheses around the 5 over 2. So I typed negative parenthesis 5 divided by 2, close parenthesis, raised to the x. Super important that you write it that way. Sorry, I have to do my table down here. So x, y. Once this is in your table, I usually just start at -3. We'll have to shift these later when we do some transformations, but for now, -3 is pretty good. So negative 0.64, negative 0.16, negative 0.4. Notice our a here was 1 again. It was -1. So at 0, it's at -1. At 1, it's at -2.5. At 2, it's at -6.25. And then at 3, it's at -15.63. So when I graph this, I'm just going to count by ones again. -3, we're almost at 0, but we're on the other side of it, right? At -2, it's at -0.16. So again, really close. At -1, we're at -0.4, so almost at half. At 0, we're at -1. At 1, we're at -2.5. At 2, we're at -6.25. So 3, 6.25. And then at 3, we're at -15. I don't know if this is big enough for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. It's at 15.6, so just a little over half. Right there. All right, so notice that negative did what negatives have in the past done, right? For transformation, it flipped the whole thing. So now we're pointing down. So our asymptote is still in the same place, right? Just our orientation to it is a little different. Try that again. Here we go. So this is still our asymptote. It's still at y equals 0. Your asymptote will always be y equals a number. So y equals 0 is our asymptote. Our domain is still all real numbers because all values of x work. Our range, however, we before said y greater than 0, but now we want y less than 0, right? It's anything below 0 works. Hopefully you guys can see that. Anything below 0 is fine now. And that's all there is to it. So your first practice, you're going to be matching graphs, and then you're going to be naming the domain, the range, and the asymptote. Don't forget, by the way, I have Zoom hours this week on Tuesday, Wednesday, and Thursday. So please log on if you have any questions. I'll post that link today, and then I'll post some reminders this week too.